Okay, let's look at the homework 8, problem number 5. Alright, we want to find an equation of the line of intersection of the two planes given here. Alright, so since we're still looking for the equation of the line, we need to have two pieces of information. And again, so one, we need to have a point, right, which we call it x0, comma y0, comma z0, right? And then second piece of information is we need to have a direction vector. Alright, so let's call it v, which is a comma b comma c. Right. Alright, so we need to find those. So the point, point is going to be a intersection of these two planes. Right. So what we want to do is, this is what it looks like. So if you sketch the picture, so you have a plane, kind of like that, and you have another plane, kind of going like this. Right, then we need to find a point on the intersection, line of intersection here. Right, so in order to do that, we're gonna try to solve the equation. All right, so we try to make it as easy as possible. So what if can we find the intersection point where one of the variable is actually equal to 0? So for example, let's set z equals 0. Right. So if z equal to 0, you have these two equations, right? So from the first one, you have 2x plus 6y is equal to 10. From the second equation, you have 5x plus 2y equal to 12, right? See if you can solve this system of linear equations. Right? So easiest way would be I'm gonna just multiply this bottom equation by, say, -3. So multiply by -3. That will get you negative 15x minus 6y is equal to negative 36. Right? And I'll just copy exactly the same equation here. So it's a 2x plus 6y is equal to 10. Right? Then we can just add these two equations up. You get, let's say, 2x minus 15x is negative 13x. Right? Then 6x and negative 6x cancel out. So it is 0. And this guy plus that guy is negative 26, right? Then we can just divide through by negative 13 to get x equals to 2, right? So if x equals 2, you can just plug in any other equation. So I'll probably plug it into something like maybe right here. So plug into second equation here. So you will get, so 2 times 5 is 10, plus 2y is equal to 12, right? So we can subtract 10 from both sides. You get 2y is equal to 2. Then you can just divide through by 2. So y is equal to 1, right? So we found a point, x equals 2, y equals 1, and z equals 0. So we can use that as the point. 2, 1, 0. Right? So we got a point. Alright, then we just need to find the direction vector, so which looks kind of like this. Alright? But notice that the direction vector of the line of intersection is always perpendicular to the normal vector of the one of the plane, and at the same time the normal vector of the second plane, right? We know how to find that, right? So here, vector, right? So the normal vector, so n1 is going to be, it's given here, it's a 2, 6, negative 3. So it's a 2, 6, negative 3. And the normal vector of the second plane is 5, 2, negative 1, right? So we can just simply take cross product of n1 and n2 to find the direction vector. All right. So once you found those, so you can, I'll let you compute the cross product of n1 and n2. Then the equation is going to be, you can just use a parametric equation or a symmetric equation. So if you want the symmetric equation, you can just do x minus x0 over a is equal to y minus y0 over b is equal to z minus z0 over c. Right? Alright, I'll let you finish the rest of it, but that's it. I hope that this will get you going.